So good afternoon, everyone, and welcome to the latest IRIS webinar. This is your host, Danielle Sumi, aka the IRIS Leatherman, speaking from the Incorporated Research Institutions for Seismology headquarters in Washington, D.C. IRIS, which recently turned 30, is a consortium of universities and an NSF-funded science facility operating programs that enable Earth scientists to perform advanced research in geophysics, particularly in seismology. Today's webinar is focused on the RV Langseth facilities, particularly on her capabilities as a seismic research vessel. Langseth operations also coordinate closely with OBS facilities, which are managed here at IRIS. Webinars are recorded and archived on the IRIS YouTube channel and also listed at iris.edu/hq/webinar. The webinar ground rules today are only the presenter, Sean Higgins, and I will speak. If you have a comment or a question as the webinar unfolds, then please clearly and concisely type it into the box on the webinar control, and then we'll have time at the end for me to be able to read that. So yes, at the end I will read your name and then question to Sean, and if similar questions have been asked, I may combine them, or if Sean has addressed them, then I'll skip them. If the webinar crashes, which I heard has actually happened once, I will go ahead and reboot it and just click the link that you received by email when you registered. Also, it helps to know if groups are watching this remotely, so if it's more than just you sitting together, please let me know. Before we begin, I also want to remind everyone about the upcoming RV Langseth New Users Workshop, which will take place on the Saturday and Sunday before the AGU fall meeting, and Sean very graciously has the UNOLS website up. The purpose of the workshop is to introduce early career scientists and simply new users to various facets of conducting marine seismic research. Topics covered will include a review of the RV Langseth, as well as sessions on technical support, cruise planning, and data collection and management. And you can find more information on the UNOLS website. So finally, today's presenter is Sean Higgins, who is the director of the Office of Marine Operations and senior research scientist at the Lamont Doherty Earth Observatory at Columbia University. And so without further ado, here's Sean to talk about the RV Langseth facilities.
Thanks, Danielle. I'm happy to be here today to participate in this webinar. And talk further and introduce to maybe new folks that aren't familiar with the RV Langseth and its role within the academic fleet of the U.S. Just a little bit of background. I started with the UNOLS webpage because the Langseth is one of approximately 18 research vessels in the academic fleet. It is the only ship that serves as a national facility, and we'll talk about that a little bit more. But I'd like to point out simply the resource that UNOLS is. The UNOLS office located up at the University of Rhode Island has tremendous amount of information on the ships, the scheduling, the committees that support all the vessels from the community, the meeting schedules, forms that are required. So I would encourage everyone listening that this is a great resource. It's a new website that was just launched here as well. You'll notice the ship time request system is prominently on the home page here, as there are links to all the committees and upcoming events. So I would encourage people to use this as a place to go to, and certainly Annette De Silva and John Alberts, who manage the office there with other colleagues, are great personal resources and stuff for all of the UNOLS community. I'd like to, before I launch into my presentation, highlight a few other online resources that provide a huge amount of information. Most of you were sent around the brochure that there's a link to here on the OMO website, the Office of Marine Operations here at Lamont that operates the Langseth. That brochure can be downloaded directly from this. This was a product developed and led by Steve Holbrook, Graham Kent, Donna Shillington, and others to talk about all the capabilities as well as the potential uses of the platform for the U.S. science community around the world. And within this website, we have a lot of information, specific information related to the vessel, the specifications, layout diagrams, laboratory spaces. There's a picture of the main lab here. A lot about how we go about knowing where we are in the world with all our geodetic parameters, support services, instrumentation. We have a whole section on cruise planning that goes down for people that were interested in developing a cruise, information for PIs, for chief scientists, for cruise participants, information on the seismic equipment. So a lot of the detail that you can go into that I won't obviously have all the time to cover today, but just point out that this is also a huge resource of information for all the technical support that we offer on the vessel. From that site, you can also link into another great community resource that's based here at Lamont, IEDA, Integrated Earth Data Applications. And within that is the Marine Geoscience Data System, where ultimately all of our data is housed. This is just a link to a site here from one of our cruises, Marcus G. Langseth, Cruise 1208. There's another example here from the seismic project information for a cruise 1110. But basically from cradle to grave, as it were, from going from the data collection to ultimately data storage, you can link to that from the Lamont webpage or from IEDA directly based on the cruise number, location, and all that information will be there. So this is a picture of the Marcus G. Langseth here as we entered New York Harbor for the very first time here in June of 2014. Even though the ship is operated here by Columbia University, most of its early years since 2008 were spent in the Pacific Ocean, and it was only in 2013 that we moved into the Atlantic Basin, and we're doing cruises on both the eastern and western sides of the North Atlantic here over the last year and a half or so now. But we had a chance when the ship was coming into New York to get a helicopter up to take this beautiful shot here in front of the Statue of Liberty here. And I've pulled a few things from the seismic brochure to really highlight, I think, some of the key elements. The Marcus G. Langseth just joined the academic fleet in only 2008. This is our 7th year of operations. We have a special focus, obviously, on the marine seismic within the U.S. fleet. We operate the ship here at Columbia on behalf of NSF under a cooperative agreement. As I mentioned earlier, the Langseth is distinct in that it's designated as a national facility, so the National Seismic Imaging Facility, and it serves a very broad community within the earth sciences, serving a variety of science proposals, range from geohazards to subduction zones to mid-Atlantic ridges to ocean plateaus and numerous other activities that have been proposed for use of the vessel over the last 6-7 years. We're governed by a oversight committee called the Marcus Langseth Science Oversight Committee, which is chaired by Dale Sawyer and has several community members that serve as our oversight committee and provide advice to us and NSF. It is the first 3D capable seismic vessel in the fleet. Seismic research has been initiated here at Lamont a long time ago, back in the late 50s, early 60s, with its early ships on the Vima and the Conrad. Significantly has grown in capability over the last 50 years. But the Langseth represents the first ship capable of actually doing full 3D scale seismic in the academic ranks really around the world. And combine that with the existing 2D capabilities, the very well-tuned seismic source array, it makes for a very powerful seismic facility to serve the U.S. science community. In addition to individual science proposals and things like that, the seismic imaging facility, supports many different programs and stuff within the science community. And included among those are IODP, GeoPrisms, Ridge 2K, Continental Dynamics program, obviously heavily tied in, as I'll discuss, with OBSIP for all the active source and passive source work that we've done with them for the last 6-7 years, and obviously tied in, with IRIS as well because of that. The facility has a broad range of capabilities for imaging the ocean, the seafloor, as well as we have general oceanographic instrumentation as well. But just to highlight the 3D seismic capability, we can tow 4 6-kilometer long hydrophone streamers. We have a dual air gun source. We have a long offset capability, possibility of towing up to 8-kilometer long streamers. In 2D mode, we can do that with 2 of the streamers in that mode. So it's very flexible from single to 2-streamer to 4-streamer work behind the vessel. We have a tuned linear source array with 36 air guns towed in 4 9-gun arrays. Each has about 1,650 cubic inches for a total of 6,600 cubic inches available. We have a Kongsberg multi-beam swath bathymetry system, 1x1 array, so it's a large system capable of very good deep water mapping. The Knudsen 32 system sub-bottom profiling at 3.5 kilohertz or chirp. We have an ADCP on board, 75 kilohertz. All 3 of these sonar systems are located in a sonar pod that's connected to the bottom of the vessel. In the labs, we have Seabird thermosalinographs. We support XPT launching for velocity profiles. We have a Bell gravimeter on board. Tow geometrics magnetometers. We have 2 of those for some redundancy. And we have an uncontaminated seawater system for other measurements like underway PCO2 that we do for Taro Takahashi's sort of worldwide survey that's ongoing. This is a picture here of the main lab. And so within this, there's all those different data strings from the streamer data, from all the sonar data, weather data, so cameras around the vessel. There's about 60 screens there that are pictured here, but this is the main hub of activity for the science party while on board for seismic cruises. We support, behind this picture, about 160 terabytes in onboard storage, numerous servers that support access to this, as well as processing capability on board as well. We also get third-party support when we can. We have Kahuna came on board to bless the ship in Hawaii with the help of one of our MLSOC members, Sandy Shore. So we look for external support wherever we can. Just to give you an idea of some of the other external data sets that we often collect during our seismic expeditions, on the left here is the PCO2, collected from this 5,300 kilometer long survey up in the Arctic during one of the record low ice lows here a couple years ago with Bernie Coakley's cruise. A really unique data set documenting surface water PCO2. And from that same cruise, looking at some multi-beam data, looking at ice gouging in the shelf there in the Chukchi. The vessel is a global vessel that operates in waters as shallow as 20 meters or roughly on continental shelves to the deepest parts of the ocean. As I mentioned a little while ago, we work quite closely with OBSIP and the instrument pool, heavily tied into the bulk of our work throughout the world. It's rare that we seemingly don't have lots of OBSs either already down as passive instruments or that we deploy either ourselves or with the 2-ship operations. It's literally been hundreds of instruments over the last 6-7 years that have been placed. Most recently on the Eastern North American Margin Geoprisms cruise off North Carolina that was just completed about 10 days ago, where we surveyed some 5,000 kilometers off the passive margin here on the east coast of the U.S. We used there were 94 active deployments, I believe something on the order of 40 to 50 passive deployments, as well as about a few hundred passive instruments placed on land in addition to the East Coast transportable array for Earthscope, So enormous in scale, and something on the order of about 400 miles wide by 200 miles, long, and in terms of its overall scope and breadth. We had Endeavour placing those instruments during our operations, rolled them over twice, I think groups of 47 at a time as they moved them around the large survey area. On the upper left picture here was they attached a GoPro camera in shallow water to take a look at both the touchdown and the anchor release of an ocean bottom seismometer. This was in about 20 meters of water off the coast of North Carolina. Below is some of the refraction data that comes back from these instruments. And this is just a picture here of the many instruments we can pack on board. I don't know what the final numbers are, but I know we've had over 70 of these tucked away on board and on the vessel. Just to give you an example of one of these, somewhat similar to the approach we took in North Carolina, but a cruise off the Juan de Fuca plate led by Suzanne Carbat with other co-workers, Ann Trehu and Helene Cartone and Jeff Abers, where they had both land-based arrays in the red here, leading out to imaging the Juan de Fuca plate, and that included both active shooting to the OBS array as well as MCS shooting along these same lines. So essentially moving from the Juan de Fuca ridge itself to the subduction of that plate there along the Cascadia margin up along Washington here. One other thing I'd like to highlight during this presentation is the environmental compliance aspect of what we do as part of our seismic cruises. So, once you've written your proposal and put in a ship time request with UNOLS for, that proposal, and as that's ultimately reviewed and, positively reviewed, and that gets handed off to the operations group at NSF, one of the key things that we first have to start out with, and it's governed by this document that I've highlighted here on the left. In 2011, we completed a programmatic environmental impact statement for the Langseth and for marine seismic research. That's the guiding document in back of the work we do, along with other environmental laws that we're required to follow. So for essentially every cruise funded by a U.S. agency requires an environmental assessment under the National Environmental Protection Act, NEPA. Based on this analysis of the findings of the EA, NOAA Fisheries will issue two important permitting authorizations. One is called an Incidental Harassment Authorization, which is an IHA for short, which you may hear that term. That's governed by the Marine Mammal Protection Act, and also a biological opinion, which is a separate permitting document that's issued by the Endangered Species Act under that act as a requirement. And so for every cruise, as you move forward in the process of both doing the scientific planning, Holly Smith, the environmental compliance lead at NSF, is heavily involved with us here at Lamont to develop the EA with one of our consultants. Below, at the bottom here, I've given an example of sort of the acoustic modeling that's done here at Lamont. Helene Cartone is our chief scientist here within the office, and she carries out our acoustic modeling that's included with our EEA, and ultimately drives, how we will mitigate in the field. We carry 5 marine mammal observers, or protected species observers now, as they're called, that work on the vessel throughout the period of the cruise with the authority to require us to shut down or ramp down, as it were, depending on where any of the species that are in the permit are found relative to the distances outlined in the modeling that we produced. So they create an exclusion zone and buffer zones around the vessel that we basically provide, mitigation for any protected species as outlined in our 2 permits that we have. I would just indicate this is a significant effort, and really NEPI should be well aware of this, of the compliance aspect of what we do. So we try to work even earlier now than we used to. The recent East Coast cruises that we've just carried out this year were some of the most complicated that we've undertaken with respect to working on the borders of several states along the East Coast, in addition to the federal government requirements. And so can't emphasize enough the importance of understanding the environmental compliance that will govern your particular cruise. Certainly every cruise is different, but it's certainly, outreach is something that's very key in this, reaching out to local communities and participating as a PI in this process. Now, jumping to how Lamont itself, here at the Office of Marine Operations, we have a Marine Operations Manager, we have a Technical Service Manager, and stuff here that basically organize the shipboard crew and the facilities and the equipment on the vessel. From the technical service support side of things, we have a science support plan that basically we develop as a cruise-specific document. So as soon as we know that your cruise is going to be sailing, there's a chief science officer or lead science officer assigned by our technical service manager, Jeff Rupert, to this cruise. This is just an example from a recent USGS cruise with Deborah Hutchinson. We have the key people that are involved in compiling this document. On the right was basically give you a rough idea of all the detail that we go into for documenting your cruise, so that we know, where it's going to be, when it's going to be, the permits, any export controls, hazardous materials, any specific issues related to shipping, fishing, or diving in the area, physical obstructions, the weather at that time of year, who's all participating from our side and the science party. We can sail up to 55 people on the vessel, which includes a 20-person crew. Usually up to about 9 or 10 technical staff on a 2D cruise, maybe up to 14 on a 3D cruise, and then 5 mammal observers, leaving anywhere from about 15 to 20 berths open for an average science party. Within the rest of this, we have all the details related to gravity, magnetics, the shooting plan that to be followed, the streamer, how the recording system will be set up, any of the acoustic measurements, the QC processing, all the other sonars, and so on. So it's a very detailed document. It's meant to provide, and in some ways provide, a contract between ourselves and the science party, so that, ahead of time, before we go out to sea, we've clearly documented the plan that everybody's in agreement with. We've covered all the primary, secondary, or tertiary, goals and objectives of the expedition, and make sure that we've accounted for the status of any of the equipment on board and any issues there. So all that we try to start up in advance. We found it to be it's a living document, but I think it's proved to be a very powerful one in communicating a lot of the specifics for a cruise-by-cruise basis. We bring other tools to bear here as well. We lease a license from a company that develops SurvOpt software. This is an industry survey tracking planning tool. This allows us to put your exact track lines into a predictive survey tracking, and it works live on the vessel as well. But it allows us to give real-time reality to, and includes all the aspects of turns that you can organize in here, downtime expected for maintenance, you can build that in. So it helps to really provide an accurate estimate of the time it most likely will take to shoot your particular cruise. And so one of the things we really encourage is Jeff Rupert, who's got about 30 years of industry experience as our technical services manager, came from industry. Several of our lead chief science officers have 20 to 40 years experience in industry. So we're really blessed with an enormous resource here in terms of just the personnel, that we would encourage any prospective PIs to contact us here at Lamont as early as possible to really talk about their objectives. One of the things we found with encouraging that is that these guys are quite creative in coming up with solutions to maybe the imaging issues that you're looking to achieve, and it can advise really on the best ways and opportunities to get what you're looking for. So I would certainly, it's one of the first stops you make as you start your proposal writing, is to really look at this ahead of even putting your ship time request in, is to really work with our group here at Lamont as early as possible that can help bring some of these tools to bear. This is just an example of bend coverage that we also track while we're shooting a 3D. This is from the Galicia Basin cruise with Dale Sawyer just last year, and this is just looking at the field coverage of what we were able to do within the box, the 3D box that he was shooting. It's very much like mowing a lawn, or where you're moving back and forth to get the all your grass cut. That's very much the same way 3D works within a box. You're trying to basically fill in that cube. And so by being able to track that in real time, you can identify areas that may need to be infilled because of a maintenance issue or weather where you missed a certain section of a line. These are just some of the 2D and 3D products. Donna Shillington will be giving a discussion on the science that comes out of the Langseth facility, I believe on December 3rd in a follow-on IRIS webinar. But just to give you an idea of the breadth of the different types of detail that's been worked on in your upper left is an example from the Church GC with Bernie Coakley, looking at some of the survey results from that 2D survey up in the Arctic. On the right is a picture that was annotated by David Scholl as part of the USGS cruise up in the Bering Sea, looking at some of the methane hydrate features that were identified through that. He basically created this picture for us here up in the Bering Sea. And on the bottom left is the 3D cube collected by Nathan Bangs off the Costa Rica cruise off the west coast of Costa Rica back in 2011. As part of our efforts here behind the scenes and stuff, and in terms of keeping track of our performance and trying to look at performance metrics, one of the things that we look at is kind of borrowing from industry. We create summaries on a cruise-by-cruise basis, year-by-year basis, minute-by-minute basis, where we look at the total time the streamers deployed and retrieved, the time it took for that, the source deployment, retrieval, recording time, line changes. And then in the black here, we look at sources of downtime. For this summary was actually for 2011 cruises all combined. And so we're looking at, the system was, operating almost 2,900 hours over that course of that year. During that time, we had almost 90% overall uptime, with the biggest downtimes for mammals and weather, which accounted for about 5%, and then other issues related to maintenance along the way. Just to give you some idea with perspective to industry, anything over 70% is considered good. Anything over 80% will get you large bonuses. So the uptime for the vessel, certainly over 2011 during this example here, was excellent. And, so we're very proud of that part, but also I think just to point out that we're following this all the time. So this is what helps us plan for upgrades and overhauls and improvements that we seek to make with the system over time. And there's been a lot of changes to the facility, which I'll talk about, and things that we'd still like to improve moving forward to allow for even more science to be done. Just to touch briefly on, we've done a few other cruises that are non-seismic, so I'll just highlight, a couple here. One was a coring cruise we did in the Line Islands with the help of Oregon State's group there for the coring. We included MST vans and other support there for CTDs and multi-cores, and a couple shots of that equipment being deployed on the Langseth there. And I will note that one of the big reasons we opened up the side of the vessel here to include the A-frame. None of this open area was original to the vessel. It would have just gone straight back to the stern on both sides when it was strictly a western Western Geological Survey vessel for most of its early life before being purchased about 2005. And it was modified through a shipyard in about 2006 to be able to create areas of deck space that support other types of operations. Just a picture of one of the wet labs that was set up for this particular coring cruise for splitting, working with the multi-cores. This was when we supported a Jason cruise up off the Pacific Northwest after the Thompson had mechanical issues. So we moved the Jason cruise onto the Langseth, which happened to be out there in Astoria, Oregon out there. And this was just a view of some of the setup for that with the various pieces of instrumentation, the Jason, the Lars, and the winches required to that. In addition to, on the top deck of the vessel, up just out of view here, we had additional 2 or 3 support vans, included all the equipment for driving Jason at depth. And this is just an example of one of our 2 dry labs up on the forward starboard side that includes various refrigerators, freezers, acid cabinets, millipore systems, and things to support other oceanographic instrumentation. So looking forward, this is just a view that was put up with the GoPro camera here. Basically looking out during the Canales cruise off the Azores with some of the towed equipment off the back of the vessel here. And it was a nice view looking forward out here. There was a nice rainbow up ahead here, but give you a little bit different perspective of what we're out there trying to look at in the deep sea there. And lastly, I'd like to bring over just an example that Nathan Bangs was nice enough to present, but give you an example of what the big difference between looking at a side view for 2D surveys versus the power of a 3D survey in terms of what it allows for ultimately scientists to work with. This is a small movie he highlighted here just to give an idea of how you can drill down through various slices to follow faults and other structures and folds. This is just off his cruise off the Costa Rica and one of his first data cubes off here, but I'll let that play through here, and I'm happy to take other questions. I tried to leave enough time here to talk about any details that you might want to go into further.
Well, thanks so much, Sean. There is a question from Jess Lodwick who asks about the post-cruise reports or data reports and that they used to be publicly available, and she wonders if that's still true.
The post-cruise data reports are usually all available, usually available through AIDA. So we usually, as we get those data reports from those, are usually included as part of what's on within the data system here, if that's what she's referring to. So you would have the cruise blog, daily field logs, all the navigation, the science report for the cruise, any of the technical reports. As I mentioned, we bring back, we keep all the copies of data on the vessel for seismic cruises is kept in triplicate. We keep a redundant copy, and then we bring a copy, obviously can be used on board by the scientists, but we bring back a full copy of the data to work, and we go through R2R with Bob Arco, and all of that data is transferred to the Marine Geology Geoscience data system, and so you can access for any of our cruises all of that information here.
Great, and I actually have a quick question. So I've been on 2 Langseth cruises myself, and I remember one along the Juan de Fuca. I was actually on the coast cruise with Steve Holbrook, and we had a lot of problems with just, fisheries and different things and permitting and whatnot. So just thinking of all of that, I saw Steve just have, incredible grace under pressure. My question for you is then, what is the biggest piece of advice you could offer Langseth PIs?
Patience. No, I would think, I think it's a combination of many things that go into there, and that specific example you uh, spoke about was an interesting one in that originally all three of the Cascadia cruises that were part of, uh, let me go back to here. There was also this, you'll see it on here embedded in this as well. This was your Cascadia cruise that Steve Holbrook led. This was all three of these pieces, Anne Trehu's portion, Steve Holbrook and Graham Kent's portion, and Suzanne Carbot's portion of this cruise were originally bundled by the National Marine Fisheries permitters as a way to permit that whole range of activities. Prior to that cruise, there was a decision made that they needed to be split up and permitted individually. That caused some of the particular angst involved with those cruises, but I think highlights again the sensitivity for environmental compliance that we have to take into account, especially in coastal regions. We're working out on the Shatsky Rise with Will Sager and June Korinaga. You don't typically have those sorts of issues. But certainly when you're working in areas that are heavily fished, have the potential for mammal migrations. There was a particular issue here with the southern orcas coming out of Puget Sound. They were worried that they hadn't seen them, and so one of the issues was to go out and find where this group had gone for feeding, as they were at the time and considered an endangered subspecies, I guess, if you will. So there's numerous issues that come into coastal regions in particular that make it challenging. And in addition, while there were some environmental concerns raised with fishing and these groups of orcas and whales on the west coast, on the east coast, it's been issues related to the Bureau of Ocean Economic Management opening up the potential for oil and gas surveys off the east coast of the U.S. that coincided with our cruises in the last year. And that's attracted attention from NGOs and others that are concerned about that as well. And so in any of these areas, we want to be able to work with the local NOAA offices, with different groups in these areas. So it becomes part of the thing you have to be aware of, in addition to the science that you're trying to achieve. We want to be able to do as much as we possibly can to support the science, but it has to be within the bounds that we're doing it safely for in the environment and as well. And so there's trade-offs there in both perhaps the design at times, the timing of the particular cruise, that we would try to maximize the ability to go out and do as much as those surveys as we possibly can. But it's something increasingly around the globe, and a lot of countries are developing their own rules as well. So we have to take it, into account wherever we go, whether or not the country has its own rules in addition to what we're required to follow with NOAA fisheries.
Great, thank you. Alberto Lopez from the Puerto Rico Seismic Network has a question, and he asks, is there a guide for making the science support plan, or are science support plans available as a guide for anyone interested in writing a proposal? And also, are observers included in the proposal?
The observers are not included in the proposal. We include that as part of our operational cost. Underneath technical services, we have support that we would build in to that is covered there. So it's covered along with the technicians as well from the operational side. So that's a cost we would build into our proposal here to support that cruise. But we provide examples of the science support plans. Much of it comes directly from our cruise planning resource online, but for any new science parties that we are made aware of in our next year's proposal planning, We're in the midst of that process right now, determining which cruises will be sailed next year. We typically meet with all the PIs in person if we can, places like AGU or other places. And one of the first things we do is give them a copy of a science support plan from a similar or another cruise that would give them that information. So that's available to anyone at any time. And and like I say, much of that same information that we package is in the cruise planning web pages at Lamont as well.
Okay, great. So I think that's all of the questions, and I just wanted to take another minute to say, to remind everyone about the New Users workshop on the Langseth being held by UNOLS the Saturday and Sunday before AGU, and to register. And I think registration is the deadline is at the end of the week. I also wanted to as Sean mentioned in his talk, but I wanted to remind everybody that this is the first one of a two-parter, and that Donna Shillington will be talking on Langseth science on December 3rd. So Sean was very much correct in what he said regarding to, that webinar. And finally, Sean, I really want to thank you so very much for your talk today. And I think it was incredibly useful and just really insightful into seeing kind of the operations side of the Langseth. So thank you.
Well, you're very welcome.
All right. Well, thanks. And that concludes the webinar. Thank you very much for attending.